Alright guys, let's go over to polyatomics now. So first let's figure out how to write the ionic or chemical formula of ionic compound with a polyatomic ion from the name. Okay. Now how do we know if we are dealing with a polyatomic ion? Well, one of the key giveaways is that the polyatomic ion is going to have this 8 ending. Okay, so if I'm looking on my polyatomic ion cheat sheet, I notice that majority of my polyatomic ions have the ending 8. Most of them, but not all of them. We'll get to those later. Okay, for example, I got acetate, carbonate, chlorate, chromate, sulfate. You get the picture. Okay, that 8 at the ending is going to let me know that I have a polyatomic ion. Alright, just like everything else, now we're still applying our cross, our crisscross, or crossover rules for this, okay? Just like anything else, we're going to write our symbols first. Have an Na for sodium, sulfate, found sulfate over here, alright, SO4. Now I'm going to hold off on writing the charge, okay? I'm off writing the charge. What is very important is that we need to keep in mind that we should have parentheses for these polyatomic ions. Okay? So let me just write a parentheses because I always want my charge on the outside. I always want my charge on the outside. I see that it's -2. I know that my sodium is +1. Okay? I'm going to cross over, so I'm crisscrossing down, just like that. Just like before, same rule applies. So let's rewrite this over here. Got my -2, I got my SO4 +1. I am going to keep my brackets, my parentheses. Okay, this one should actually be on the outside. Alright, I'm going to remove my charges because I don't write charges in my subscripts. I'm going to simplify the numbers and remove the ones. Now, because I am removing the ones, SO4 is a 1 on the outside, I do not have to write the parentheses now. I only have to write if it's anything greater than 1. So I'm going to remove the parentheses. Okay. There's my chemical formula. Let's try another one. Alright. This one's a little bit trickier just because, I wouldn't say it's trickier, it's just, you can't be intimidated by this. The only thing that's different, guys, is that on this one, we have, let's see here. I have, well, hold on, I got a Roman numeral. Okay, remember Roman numerals tell us that we're dealing with transition metals. Alright, then I have an 8 at the end of phosphate. Okay, so I have a transition metal and a polyatomic ion. Now, nothing is going to change. The rules are going to stay the same. I just have transition metal instead of your average metal. Okay? So I'm going to do the exact same thing here, guys. So let's write out our symbols. So if I look at the periodic table, find that iron is Fe. I look to find phosphate on my polyatomic cheat sheet. I see that is PO4. And I'm going to keep remember I have to keep my ionic charge on the outside. So I'm going to write parentheses. It says that it's a -3. Remember that our Roman numeral is always going to tell us the ionic charge of the transition metal. And because it is a metal, it's going to be a cation which is a positive ion. So we have +2. Okay. I'm going to cross over the charges from top to bottom. 2 will go right here. The 3 will go right here. All right, let's rewrite these. So if Fe PO4. I'm going to write my parentheses. I'm going to write my charge. -3 +2. Let's remove the charges. Okay, I have to make sure that I am simplifying. Simplify. Okay, I can't simplify 3 and 2 any further. I don't have any 1s, so looks like I'm done. There is my final answer. And remember, guys, what these subscripts are telling us is that I have 3 iron atoms and 2 phosphate atoms in this overall compound. That's what that number is telling us.